This is the ultimate guide to starting electronics in 2026. So in this video, I promise I'm going to discuss 3 main topics that need to be covered before you start electronics and explain each of these in a little bit of detail so you have a more overview and a more better idea of what electronics really is and how you can make your own electrical projects. So the first part of this video is going to be different components. So we're going to discuss capacitors, transistors, resistors. The second part is going to be the brains of your electronics. So should you use a microcontroller or a microprocessor? And the third part is going to be different tools like 3D printers, soldering kits, and other essential tools you might need in order to make electronic projects. So let's go into the first part of this, which is components. So I'm going to assume that everybody in here already has a basic idea of how electricity works with voltage and current and all of that. So here are the 4 main components I would say with electronics. You have your capacitor, your resistor, transistor, and then inductor. So let's go with the resistor first since it's the easiest part. So a resistor pretty much just limits current, and it can also limit voltage within an electrical system. So let's look at a simple circuit first, which is a voltage divider. So current and voltage and resistance all have a relationship called Ohm's law, which is voltage equals current times resistance. And we can use this to manipulate our electrical circuits so we can decide how much power a certain component of the electrical circuit can get. And that's what resistors can come in handy with. Next, let's go with transistor. So I would say transistor is the second easiest part. The math behind it might get a little complicated, but essentially it's just an electrical switch. So the 2 outer pins are connected only if the middle pin is connected to power. And that can be used as an electrical switch, which is how I made my 4-bit transistor computer with over 350 transistors, because it acts as a switch so it can be used to turn on and off certain electrical components depending on what I program a computer to do. And these things are what your modern phone is actually made of, which is electrical switches. Now let's get into capacitors and inductors. And these are going to be in the same category because they are essentially the same thing. They are electronic storage devices. So a capacitor stores electrical voltage, and an inductor stores electrical current. And the math behind this can get a little complex because they release energy exponentially. So all the mathematical equations is all exponential functions. But essentially, if we look at a DC electrical circuit, which is what most electronic projects are going to be based off of, DC meaning direct current. So it's like a battery operated stuff, not the stuff out the wall outlets, which I assume nobody's going to use for a basic electrical project. Capacitors act like open circuits, and inductors act like a short circuit. Essentially when time equals infinity, so in a long run. And this could be useful for some circuits, like if you want a circuit to release a pulse for a second, you could use a capacitor because eventually it's going to act like an open circuit, if that made any sense. And then you can combine these two together to make oscillating circuits, to make different timer circuits, to make an astable multivibrator, which is what I use again in my transistor clock to make a kind of pulsing circuit. But essentially, these are just energy storage devices. So you can store energy and release energy within your circuit. And that's the basic idea of how these 2 components work. So now let's go into the second part of this video, which is going to be what brains you would want to use for your electronic project. So this is arguably the most interesting part of this whole video, and the part where if you say electronics, this is what people kind of cling towards. And this is an Arduino and a Raspberry Pi. So this is what's most likely going to power your electrical system so you can do something useful that you want it to do. So an Arduino is a microcontroller, which means it controls other elements of a circuit. So you can make it do what you want it to do, and you can code it too. It's programmable. This is a Raspberry Pi, which is a microprocessor, which can process data and do more complex stuff. So basically, if you want to control something very basic and low maintenance, you would use an Arduino like this. This is an Arduino Mega. But if you want to do something more complex, like facial recognition, some AI stuff, then you would use a Raspberry Pi. But an Arduino is about $15 and this is about $100. So you really need to like make sure you know which one you want to do for your project, but it's not too hard to figure it out. And you can use different sensors for both of these to make your project do what you want to do. So let's say you want to display data, you can use an LCD screen like this one right here to display the data you want. If you want to control the LCD screen, you can use a joystick. And if you want to save stuff to the LCD screen, you can use an SD card module. There's many different modules you can use with this. Temperature sensors, there's humidity sensors, daylight sensors, light sensors, sound sensors, whatever, motion detection, and you can use it for all your projects. But you need to know a little bit about what sensors exist so you can make a project that's reasonable for your needs. And we're not going to go over all the sensors in this video because that would be a pretty big video, but I just want you to be aware of it, that if you do have a sensor, you would need to know what it can do for your project. And that's really it. So if you want to get started with Arduino, you would need to download the Arduino app and then you can code it on your computer. But if you want to get started with the Raspberry Pi, which let's bring that back in the frame, you would need its own monitor, its own keyboard, and its own like mouse, because essentially you code directly on this. This is a computer. And that's really the big difference between the both of these. Now let's go to the last part, which is what tools will you need for electronics. So first things first, one of the main tools you'll probably need is a soldering iron. Soldering allows you to connect electrical components together in a more permanent way than just kind of like a breadboard and sticking it together. But soldering irons are typically pretty cheap on Amazon. You can get one for about $15. Another thing that might be useful is this DC power supply. So I can put any voltage I want between 0 and 30, and I can essentially control how much voltage my electronic projects get with this, which saves me a lot of hassle with fooling with batteries or trying to get a certain power supply for a wall outlet, because I can just turn this thing up to the exact voltage I need for my electronic projects. And this thing right here is probably about I'd say $60 I paid for it. It's very useful. It's a little more expensive, so you have to be kind of dedicated to electronics if you really want one, but it is very good because you can put the exact amount of power that you need. And I said another thing that you would need too would be a 3D printer. This one is by far the most expensive thing you'll get, but in the recent years they're pretty cheap. They're about $200 for a solid 3D printer that will work for most of the needs of an average electronic hobbyist. And this one's an i3 Mega. This was about $250 5 years ago. It still works really well, but it's a little more of an investment. But it comes in handy a lot of times if you want to make a custom housing for your electronic projects, or if you're trying to make this certain shape or design for a very custom thing you're trying to do for your projects. And there's a lot of free 3D modeling softwares out there. So really all you need to do is buy a 3D printer. And then once you buy the 3D printer, you should be set, and you don't need to spend any more money on 3D modeling softwares if that's another one of your concerns. And the filament is also pretty cheap. You can get a kilogram or a roll of filament for about $20. And if you never printed before, a kilogram is a lot. It's a lot of filament. It takes a long time for you to run out of that, unless you're printing like a life-size human version of yourself or whatever. This will be the last section of the video right here. And these are basic tools that you probably need first. Out of all the stuff I said, you'll probably need these tools first. And we have a wire cutter, wire stripper, which if you're fooling with a lot of wires and electronics, you'll need a way to take the insulator off so you can see the bare metal. And then we have wire cutters, so you can cut the wires. And I like these as wire cutters instead of this one because it has a little fine tip, so you can really get into a small electrical circuit if you need to. And then you need a voltmeter, which is what this thing is, but it does more than that. It measures the voltage of certain points in your circuit. It measures the current, the resistance, whether electricity can flow through it or not, and all sorts of other stuff. So this is also fairly cheap. You can get a fairly cheap one for like 15 bucks, and you get tools like this also pretty cheaply too for like $10. So this is a little bonus segment now of the video, and that is how do you learn all of this stuff about electronics easily. And people ask me all the time in the comments, like, what books do you read about it? I really don't read a lot of books about electronics because it's kind of boring, but I am in school for electrical engineering, so I am learning throughout my classes. But I use a lot of AI, a lot of YouTube videos too. But I kind of started at such an early age, and I kind of just figure it out through a lot of testing and playing around with stuff, because that's how I learn best, and that is what I find most enjoyable. So I mean, I burnt a lot of electrical circuits. I caused like one small fire and whatever, but I mean, you gotta just play around with it and learn and use AI and other YouTube videos in order to enhance your needs. And that's the whole point of this channel right here, is to educate people about electrical circuits, mainly computer architecture right now, but in order to help with their education and the whole world, to give free education out so we can improve our society as we progress. But thank you for watching this. All the links, we'll have some Amazon links in the description if you want to go check out some of the stuff that I would recommend and that I talked about in the video. I'll probably will be affiliate links, but I had to set up a whole profile, all that first. The other links too, the Discord, the Patreon, whatever, my schematics, if you want to buy some of my circuits, all in the description. But thank you so much for watching, and I hope you come back Sunday to learn about computer architecture. But thank you.